Now that we've seen what makes a hurricane, let's take a look at the life cycle of a hurricane and look at the different stages and categories of a hurricane. First of all, the strength of a hurricane is proportional to two things. One is the difference in air temperature between the tropopause and the surface, and the other is the potential for evaporation. Now, this temperature difference between the tropopause and the surface, we're looking at surface temperature and tropopause temperature, looking at how much the temperature drops. In other words, we're looking at the environmental lapse rate. Yes, we are looking at the instability of the atmosphere. The larger the difference in temperature, the more unstable the atmosphere is, and the more likely you can have thunderstorms grow, which eventually become part of a hurricane. And if a hurricane moves into an area where there's little instability or no instability at all, then it will weaken a hurricane as well. The other factor in the strength of a hurricane is the potential for evaporation. Remember that warm water is the fuel for a hurricane. And so if you can evaporate water, you can always add energy to the storm. Now, imagine you have a mass of very humid air, say 97, 98, 100% humidity, moving over the warm water. Even though the water is very warm and ready to evaporate, the air won't be able to hold a whole lot more, and so the potential for evaporation is very low. Whereas if you have a dry air mass moving over the water, there's a lot of room for more water. It's got a low relative humidity, so there's a lot of room for evaporation to occur. This is why the tropical waves from the coast of Africa are so ideal for hurricane formation, because not only do they trigger the low pressure system needed for circulation, but since it's really dry coming from Africa, there's room for a lot of evaporation, and you've got a lot of potential for storm growth. Okay, so we've got ourselves the potential for storm growth. Let's get it growing. At first, you have a few thunderstorms working in an area. When they start, you get a lot of thunderstorms in an area, we start calling that a tropical disturbance. That's all it is, just a disturbance, a region where you have a lot of storms, thunderstorms, just in the area. Once they start working in unison and start forming a common low pressure, they become known as a tropical depression. Then that circulating motion around the low pressure starts to develop a little bit more, and the wind speeds pick up, and you get a very clear circular formation, which we call a tropical storm. And that occurs when wind speeds come between 35 and 64 knots. And these are sustained wind speeds, not wind gusts. Once the wind speeds reach 65 knots or 74 miles an hour, it becomes a hurricane. This is the stage where you start seeing that very ideal hurricane. And major hurricane would be category 3 or higher, 96 knots or 111 miles an hour or higher. At any of these stages, the storm can start dying out if it reaches cold water or land. In other words, you cut out the fuel, the hot water. So we talked about hurricanes and major hurricane being category 3 or higher. That leads us into the Saffir-Simpson scale, which is basically just the categories of tropical cyclones, hurricanes specifically. Once it becomes a hurricane scale storm, in other words, 74 miles an hour, 64 knots, it's a category 1 storm. Then it increases to category 2. Once it hits 111 miles an hour, 96 knots, it becomes category 3. This is officially a major hurricane. Categories 3, 4, and 5 are major hurricanes. So there's 3, 4, and a category 5 would be anything over 156 miles an hour. Classic case was from a couple years ago, Hurricane Michael. We thought it was 155 miles an hour, but further investigation found a record of 156 miles an hour, so Hurricane Michael became a category 5 storm. Or it was officially categorized as a category 5 hurricane. So those were the numbers. This is what you would actually see. Tropical disturbance, like I said, is just a bunch of thunderstorms in an area. You can see there's no rotation at all. It's just a mass of thunderstorms. Here you've got a tropical depression. It does kind of still have, it has a little more of the roundish feature to it. It's developing a low pressure in the center of the storm. And having that low pressure in the center of the storm, it can start to intensify. And once it really develops that circular motion, it becomes a tropical storm. There's the center of rotation right there. And when that gets to be strong enough, it eventually becomes a hurricane. Okay, so you've got a hurricane. It's moving along. Where is the damage going to occur? What can cause the damage? Well, the first cause of damage is wind. So you have a hurricane. In this case, it's moving to the north at 25 knots. Winds are moving around the eye wall at a speed of 100 knots. Well, on the right side of the storm, winds are moving to the north. Since it's going counterclockwise, it's going to the north on the right side of the storm. So that's 100 knot for the wind, plus the 25 knot forward motion gives you maximum winds of about 125 knots. Whereas on the left side of the storm, the wind, since the winds are counterclockwise, the winds are moving to the south, which are then countered by the forward motion of the storm, so you end up having maximum winds of 75 knots. So where can you expect the strongest winds? On the right side of the storm. This is something we're familiar with here in Florida. We've dealt with this before, but there you go. There is an explanation as to why the right side of the storm is always the worst. There's a second reason why the right side of the storm is the worst side of the storm, and that has to do with the ocean underneath these winds. Remember that the ocean is pushed by these winds, so ocean over here gets pushed back to the backside of the hurricane. But the ocean over here gets pushed forward and starts piling up here. So if this were to continue and make landfall in Connecticut here, then the water would be pushed ahead on this side, and this region here would experience the strongest winds and the strongest storm surge. And so those are the two biggest causes for devastation in a hurricane: the high winds and the storm surge, which occurs on the front right side of the storm. And when you look at the storm surge, there's another factor that we have to deal with, and that's the tide. When Hurricane Matthew passed by in our area in 2016, the Daytona Beach area was rather unscathed. Yes, there was some damage to trees, wind damage. When we talk about storm surge, not much damage at all in the Daytona Beach or Ormond Beach areas. But those of you who live in Flagler Beach or Palm Coast, you may have seen more damage, because by the time Hurricane Matthew reached the Palm Coast area, the oceans had reached high tide. And since they were at high tide, that means that the ocean levels are higher, plus you have the storm surge on top of that, and as a result, there was a lot more devastation to roads and beaches up in Flagler County. In addition to this, we have this coastal flooding, which I just mentioned. You also have river flooding. The hurricane moves onto the shore and dumps a lot of rain into the area. And that rain is then concentrated into rivers, which then flows downstream towards the ocean again, flooding the riverbanks. Okay. So here's a good example of where this might happen. New York City in 2011 had a hurricane that made landfall. Wasn't too bad, but it went further north and dumped a lot of rain and caused the rivers to flood. Well, what was next to the rivers? Industry. Some industries even had toxic waste, which was stored safely, but because the river flooded, it carried that waste, the toxins, downstream into the city. And so it was quite a worry. That was in 2011. 1 year later, in 2012, Hurricane Sandy hit, and the flooding was horrible. Instantly, I remember hearing a lot of worry of the toxins that they may have had, or like what they had the year before. That didn't happen though. The reason being, in 2011, the worry was river flooding, whereas Hurricane Sandy, it was from the storm surge, coastal flooding. So the different types of flooding cause different results in concerns and effects. One last big devastating effect of hurricanes is hurricane-spawned tornadoes. Remember that a hurricane is nothing more than a bunch of thunderstorms working together in one. And so you have a number of thunderstorms that are strong enough they can actually spawn tornadoes. We'll talk in a future video about Hurricane Ivan that had a record number of 117 tornadoes.